Welcome to the first session of Philosophy 201 Introductory Logic. I am Professor Hans Halverson, and I'll be the leader of this course. I'll be joined by two assistants, Alice Van Toff and Roman Altschuler. Each one of you will have one of the three of us, as your primary instructor. So that means that primary instructor will be the person whose precept you will attend, the person who will grade your problem sets and exams, and also the person who will be available to you in office hours and for other questions primarily, although as the instructor leading the course, I'm also available to any one of you. In addition to those individual roles, I will be the person delivering the lectures, this being the first one of those, and these will all be available. The lectures will be available via video before the time you'll need them, when you'll need them in particular, as you'll see in a moment, to prepare for the problem sets. So let me start by explaining to you in terms of a flow chart how this course will go, because in one sense, this is a very task-oriented course, which is not, of course, what you might expect from a philosophy class. You might expect in a philosophy class that we'll spend a lot of time talking and discussing issues, and sure, there will be a little bit of that, but this course, the primary goal is to teach you a skill. And so that primary goal, we will be checking that you've made progress, in particular by the exams. So you'll see there in this course flow chart, the macro flow chart, that the final destination, the final goal of this course is a cumulative final exam that will take place during the exam period at the end of the semester. All exams, of course, will be administered online. You'll be able to schedule those at your convenience. Of course, you'll also be expected to obey the honor code, and these exams will be closed book, closed note. More information about those to follow, but as you can see here from the flow chart, there will be problem sets between the exams. I will go ahead and tell you, if that's scared you, the phrase problem sets, if that sounds like not your kind of thing, well, all I can say is maybe give this a chance, because I think you'll find that these are problem sets like you've never had before. So logic, the kind of logic we'll be doing, is something that doesn't get taught usually at the high school level anywhere in the world. It's not part of most standard curriculums. In fact, it's something that's quite peculiar and sits very squarely in between humanities and the sciences. And I would argue, in fact, it is the foundation for all of that stuff. And so it will be in many ways different from stuff you've seen before. So that's the macro flow chart. As I said, there's the two exams, the midterm exam, the final exam. The midterm exam should take you about an hour. The final exam should take you about 2 hours. The midterm exam will cover everything up until the midterm. The final exam will be cumulative. So I'll just say the following words about what will be on these exams. These words will probably not mean anything to you right now, but that's the way when you hear these words, as we progress through the semester, you'll think, okay, good, now I know that. I'll be ready to do that on the exam. So the first exam, the midterm exam, will cover what we call propositional logic. And there will be tasks such as translating from English into propositional logic. That's the task of symbolizing in propositional logic. There will be proofs to do in propositional logic. And there will be what are called truth table problems, which actually many of you probably have done some version of before. So there'll be truth tables, which are then used. This is the fun part for us with truth tables. They're used to check when something cannot be proven. The final exam, again, cumulative, and that might sound like it will be a lot of material because we'll be gathering material over 12 weeks. But if you look below at the note below the final exam there, this course in many ways will be more like a language course than it will be like a content course, say a history course. And that is, if you learn the skills that we want you to know in this course week by week, you will be ready for the final exam. There won't really be a need to learn new things after you do the last problem set and take the final exam. Sure, you may want to review a little bit, you may want to refresh your memory about some things, but the fact is you will have the skill set by the time we get to the end of the semester if you follow the steps we prescribe, and therefore you will be ready for the final exam. So that's the good news, is there shouldn't have to be any cramming before the final exam. Final exam topics. So we'll shift gears at mid-semester. We'll shift gears from propositional logic to what's called predicate logic. And then we'll have a similar kind of task on the final exam as we had on the midterm exam. So there'll be translations into predicate logic. There will be predicate logic proofs. There will be what's called the technique of producing models. And that, in this case, plays the same role that truth tables play for propositional logic. And that is, you can show when an argument cannot be proven. You can give what we call a counterexample to an argument. And then finally, in one sense, the hardest part of this course, this might sound a little bit paradoxical, but it's the hardest part of the course, but is learning how to argue in a persuasive, in fact, valid way where it's not fully formalized. That's one of the hardest parts, is as we get toward the very end of the course, teaching you to continue to use the rigorous argumentative methods we taught you during the semester, but without making them so explicit as we did earlier in the semester. And in particular, one of the funnest things to do with that is where you use logical arguments, logical proofs, to argue about the limits of logic itself. So you use logic to talk about logic. That's called the meta theory of logic. And that became very important in the 20th century. One of the most famous results in the history of mathematics, in the history of logic, something called Gödel's theorem, after the Austrian logician Kurt Gödel, who actually spent the second half of his life in Princeton and is in fact buried in Princeton Cemetery. And Kurt Gödel, who proved that there is something true about numbers that can never be proven. It's one of the amazing things. We won't quite get there by the end of this semester. It's a little bit too advanced for what we'll do, but we'll be on the way towards that kind of being able to see why that kind of thing can be done, why Gödel could prove that kind of result. Okay, so that's it for the exams. So let me say something a little bit more about problem sets. And this leads to what I call here the micro course flowchart. So this is sort of the flowchart of a typical week in this course. So you can think the proximate, that is for a given week right there, the proximate telos or goal or aim each week is the problem set. So that is right here. This is the thing where you focus your efforts. You focus your efforts around completing the problem set. What that means is you should begin each block, each of these micro blocks, by looking at the problem set. So this is good advice that you know when people told you how to take, say, standardized tests, right? Is you read the problem first. You read the problems first so that you know what you have to do. And then you can allot the right amount of time to each thing and so on. But in this case, the important thing is these steps in between, like reading the textbook, watching the lecture, attending precept. You should go not as a passive participant, because the truth is some of the material will seem too difficult if you don't have a reason to look at it. And so what you want to do is you want to come with thinking, I need to solve the problems in this problem set. And then you'll be looking for the information you need in the textbook readings. You'll be looking for the information you need, the tricks you need, the techniques you need, the ways of thinking you need when you watch the lecture, and you'll be going to precept with the right questions that will get you there, get you to where you need to be to solve the problem set. So in truth, although this looks just like a straight line from read over the problem set to complete the problem set, it very likely will have some loops, so to speak, where you read over the problem set, you maybe read the textbook and watch the lecture, and then you start to try to work the problem. So you read the problem set again, and then maybe you go to precept, maybe you go to your preceptor's office hours, maybe you form a group with some other students where you all talk about the problem set and brainstorm. That is something I encourage, as I'll say on the next slide. But in short, all things lead to the problem set and delivering the problem set, solving the problems on it. Okay, so as I said, I not only permit you, but we encourage you to work together in groups, to work together with other students. However, there's a simple policy is this has to be fully individualized at the end of the day, in the sense that you cannot transfer somebody else's thought or work onto your paper. That's not permitted. And that's honestly for your own good, because if you get in that situation where you're doing it on your problem sets, you will not do well on the exams. So in the exams, when you can't speak to other students, you'll be on your own. So what can happen is you can get an idea from another student, you can get help from another student, but then you need to step back and think, do I see what's going on? You need to be honest with yourself. If you don't see what's going on, you don't write it down. You plan ahead and far enough in advance so that if you're still struggling, you speak to your preceptor, you speak to me, you discuss, say, I can't see this yet, I can't see this yet. But be honest with yourself. Don't write something down that you don't understand. Okay, so as I mentioned in that micro flowchart, that there is a textbook for the course. The author's name, it looks somewhat familiar. That is me. I am the author of this book. And so in some ways, things I say in lecture may be a little bit repetitive. Actually, I wrote this book after teaching this course at Princeton many times, and I had been collecting my notes and finally thought I would like to put these together into a book. However, on the other hand, I tried to underwrite in the book. In other words, I tried not to say everything I was thinking, so that some of the things I say in lecture I'll explain areas in the book where I myself was terse. I'll also, of course, give examples that are not given in the book. But here is a particular place where I encourage you to listen carefully to your preceptors, especially if they're not me, because they will have different angles on this material. I'll also have some recommendations for anyone. Let me put it this way. Some people may ask, what is another book I could look at? How could I reinforce my knowledge of the material by looking at another book? And there is one obstacle with that. And the obstacle, in short, is different people present logical systems, the way to do logic, in slightly different ways. That's an unfortunate circumstance that there's not been uniformization. On the other hand, it gives creative thinkers the opportunity to present systems in sharp ways that they think are particularly perspicuous, particularly clear, and I've tried to do that in this book. Nonetheless, if you find that, and this is true for everyone has different ways of hearing something that work for them. If the way I write in this book doesn't work for you, I'll come up with some other recommendations of books you can look at. The book that I used traditionally for this course at Princeton in the past, I'll write it here, and I'll also post it on the Canvas site, and that is a book by an author named E.J. Lemon called Beginning Logic. It's a wonderful textbook, Lemon, Beginning Logic. It's also very old. It was first published in the 1960s, and has some antiquated language, and it, in some ways, is a difficult, challenging book. So in any case, that's your textbook. Everyone should have a copy of that. I've been told if you go to jstor.org, so jstor.org, that Princeton University has enabled access from Princeton on-campus computers and anyone using Princeton VPN and so on to a free copy of this book, which is published by Princeton University Press. I will attempt to put a link up to that. If you can get electronic access, that is just fine for me. I get about $1 for each copy of this that's sold, so this is not a money-making opportunity for me. I hope the book will be helpful for you, but it is a tool. It is meant to be a stepping stone. Again, the goal here is not for you to absorb the content in this book. The goal is for you to learn a skill, the skill of learning how to give good arguments, learning how to check whether an argument is valid, is good, or is not. And so that will be the test of whether you do well in this course. So that's it for today. We'll continue, or for this module, this particular first lecture. I'll continue in the next lecture introducing the content of the course. I'll explain why somebody would want to learn what we call symbolic logic, which is the content of this course.